Now, dealing with mechanical energy in general, okay? So when we're looking at conserving energy, we want to be able to focus on all the different parts of energy that are available, which means that the mechanical energy that is present in any system or substance is its kinetic energy plus its potential energy. Okay? So you add those two up, that gives you mechanical. Now remember, there are two types of potential energies now. So what happens is the equation gets a little more complex. So we say that mechanical energy that something has is equal to its kinetic energy plus its potential energy due to position plus any potential energy due to its elastic scenario. Okay? So it's potential. See how I use that word? There's potential that there's three different types of energies present. Now the trick is this total energy, the mechanical energy here, is always the same. Okay? So we don't ever gain mechanical energy, we don't ever lose mechanical energy. This number stays constant. It's just a switching between these three variables as the object moves and shifts and changes position. Okay? Now, when we conserve mechanical energy, things that we got to make sure that we always are keeping track of. Okay? Total amount of energy is constant. The type changes. Again, total remains the same. I've said that like 5 times now. Okay? So total energy stays the same. All right? If something is falling, okay, let's take a look at that. If something is falling, let's do something simple like a diver off of a diving board. So if we have a person who's going to fall off a diving board, and they just step straight off the board and they start to fall, okay? As they fall down, okay, let's talk about their energies, okay? At the very top, right here, all their energy is potential energy due to gravity, okay? That's all their energy. But as they fall, their potential energy due to gravity is going to decrease. Because as they fall, what's happening to them? Well, as they fall, they're accelerating. And as they accelerate, that means they're gaining kinetic energy. So the kinetic energy they have will increase as they fall. Okay? At the very bottom of the fall, the instant at the bottom, right here, not after they hit, not after they've slowed down, the second they finally just touch the bottom, all of your energy is going to be kinetic. Because if we consider this our 0 point for 0 height, you have 0 potential energy due to gravity at this point here. Okay? So as something falls, it's going to be increasing kinetic energy, it's going to be decreasing its gravitational potential energy. So if this goes down by 5, this has to go up by 5. This goes down by 10, this goes up by 10. It's proportional between the two things, okay? So think about it. Halfway down, if you're halfway through your fall, half of your energy is potential, half of your energy is kinetic, okay? Now, same idea if you're stretching or compressing, okay? If I have a spring, and let's say I hook a spring to a stationary object, and I have a mass of that. And I pull this spring downwards, okay? As I pull this down, okay, I'm gaining, or I'm increasing potential energy due to elasticity, okay, as I pull that down, okay? As soon as I let go, the spring will shoot back up, and I'm going to lose that potential energy due to elastic, okay? So the spring is going to have 0, if it's at its natural position, its potential energy due to elasticity will be 0. Anything off that natural position is going to have some elastic potential energy. So if it comes up and it compresses the spring, so the block comes up high, and we compress the spring like this, that compression, that happens also will give it elastic potential energy. So springs can both be compressed and stretched. Okay, so anything off of its natural position where it has zero potential energy elastic, we have some sort of potential energy that's elastic to it. Okay, which means as something moves or stretches or changes, we can compare the initial mechanical energy to the final mechanical energy. Okay, so we know that the initial mechanical energy has to equal the final, which means all the kinetic energies plus the potential energies have to equal the final kinetic energies and the final potential energies. Which means, and here's where it gets really fun, breaking it down across the board, that your kinetic energy initial plus your gravitational potential energy initial plus your compression or potential energy of elasticity initial has to equal all your finals. Okay, so if you take a look, the equation gets really long really fast. Okay, however, most of the time we're looking at things that either start in their natural position, or they're going to start by not moving, or they're going to start by hitting, or they're going to end by hitting the ground, so they're at the bottom of a fall. So one of the things you really want to look for in these kind of problems is which of these variables can I make zero. Okay, so if there is no spring, if there's no stretching, if there's no elasticity, this whole piece disappears. This whole piece disappears. If it's only a spring and there's no height, this whole piece disappears, and this whole piece disappears. Okay, so keep in mind that most of the time for mechanical energy problems, even though this looks really long and complex, most of the time there are at least one or two of these that we can make zero and get rid of them right away from our problems. Okay. Okay, so let's kind of wrap this up here real quick and kind of show you about the things that possibly can change as we kind of go through this, all right? We've already talked about how we have our different mechanical energies, and that these are here. And we've already talked about how we have our initials over here, where we have our kinetic, our gravitational potential energy, and our elastic potential energy, and our finals. We've also already talked about these ideas of making sure we look for everything that are zeros and be able to eliminate those things as zeros, okay? So now let's take a look at what can change, okay? So as you are actually working through this equation, what are some things we look for changes? Well, first of all, things fall, okay? So a lot of times in our conservation of mechanical energy, we have something that starts high and it falls down, okay? So as it falls, we should see a decrease in height. So this number should be bigger here and smaller here, okay? That will create a decrease in potential energy gravitational, right? As that height decreases, that velocity should increase. We could also have things that are stretched or compressed, okay? So as you stretch or compress things, we're going to change this x value here. So this could start small and become big, or it could start big and become small, okay? Either way. And again, as you're moving these or changing these, both your kinetic energy and potential energy gravitational could be converted into that potential energy elastic, okay? So as you fall, we always convert into velocity or kinetic energy. As you stretch or compress, it's possible that you convert into kinetic energy and potential energy gravitational depending on how that is changing as you're doing that, okay? One thing that we don't typically change is mass, all right? So typically speaking, we don't go in here and halfway through our process, the mass divides in half or gets cut in half. I'm not saying it's impossible, but typically speaking, when we look at these problems, we are keeping the mass the same throughout the problem, okay? That can be helpful for us. But just also keep in the back of your heads, if we get a scenario where the mass does change, we can still deal with it because we do have mass on both the initial side and the final side, okay? Now keep in mind also, these scenarios here of falling, stretching, especially falling and stretching, we could reverse that, right? We could shoot something upwards so it would move up, and we could release the stretch or the compression, and that would also cause some differences there. So we can actually get the opposite effect to happen for these also. So that leads us into our first conceptual idea here. And what we have going on here is basically a person stepping off a bridge with a bungee cord attached to them. We're going to cover this in class as a class activity and also do some more math practice with this in class. Thank you.